All right, so with me today on this episode of our expert series is Zion. Mr. Zion is a senior data scientist. He's skilled in this space. He's one of the thought leaders in Nigeria in the field of data science and analytics. He's here with us to share his thoughts and insights as regards experimentations for data professionals. And I am really sure that you would gain a thing or two from this conversation. And feel free to drop your thoughts in the comment section as well. And so I'll hand over to Zion to please introduce himself in a few minutes so you can have an understanding of his background, what he does, his breadth of experience, and how he can share his thoughts with us today. All right, thank you, Zion. Over to you.
Awesome. Thank you very much for that great introduction, David. I'm so happy to be on your show. So my name is Zion Pibowei, and I'm currently the principal data scientist at Curriculum, a technology company building fintech infrastructure for African fintechs mostly, although we're expanding into other international markets. So we build the data analytics and machine learning infrastructure to enrich the decision-making speed of fintechs when it comes to credit decisions and things around machine learning, decision modeling, and optimization, and just pretty much what every fintech needs to do to be able to optimize their credit decisions and maximize revenue for their organization. Prior to my current role, I worked in consulting, and I stayed the longest in consulting, which exposed me to different areas in data, but mostly data science, and then occasionally data engineering. I also have a very related academic background. I have a bachelor's degree in physics and a master's degree in mathematics and statistics. And of course, this has also been very helpful to my career. So I think that's a bit of a background about me, and I'm excited to be on this show to talk about experimentation and share my knowledge and insights on the topic. Thank you very much.
Wow, thanks so much, Zion. I'm sure at this point you're convinced that he's the man for this conversation. He has the breadth of experience and the insights to answer all the questions you and I would need to improve our data science processes in our organization. All right, thanks so much, Zion. So hearing about your current company, what you do, building infrastructure for fintechs, what comes to my mind is that a lot of products is involved. And this would also mean lots of experimentation, the way I see it, right? And also, first of all, I'd like you to tell us about the fundamental concept of experimentation, because I feel like a lot of things is said about data analytics, analyzing stuff, machine learning, AI. Well, really not so much is said about experimentation and the value of experimentation. Personally, for me, my idea for experimentation brightened up during Qualys. One of the speakers, I can't remember his name, he spoke about experimentation, and I'm like, wow, this is really, really amazing. So I'd like you to tell us about the fundamentals of experimentation and why institutions, organizations need to talk so much about this and also try to apply it in their business framework.
Okay, great. Thank you very much for that. And you are very correct. Experimentation is not so much talked about when it comes to the practice of data science. And most times organizations, when they want to do data science, they just jump straight into machine learning and building APIs to serve predictions either in batch or in real time, and they miss a very critical detail that actually makes machine learning models reliable, right? So for most organizations, you can do very strong data science without having to jump on machine learning yet. So machine learning is always best for use cases that you have data that is adaptive and you want to be able to make predictions. That's if it's explicitly what you need to do, right? But if you want to take decisions in other ways, there are a lot of experimentation methodologies that you can try out. So pretty much experimentation is the practice of testing ideas. So a lot of organizations want to try out a particular solution, or they want to understand their customer behavior, they want to understand patterns in data, they want to understand sentiment. And that's really supposed to be a very critical step before you even start making predictions for your users, because how can you predict something that you don't understand? So the first thing that organizations really need to do is to understand. And then when you understand, you can make some really quality decisions. So experimentation is a way for you to actually achieve high quality decision making in your organization. Experimentation is one solid way, is the golden standard, for really testing ideas and validating your ideas. So you want to take this decision. How does it impact your user behavior? How does it create any cost to your business KPIs? and things like that. So you just want to experiment. And when you're experimenting, you're testing against specific business KPIs, and you want to know how what the impact is on those KPIs. And of course, there are different levels of experimentation too. There are the least rigorous methods that any organization can try. So most times when people hear about experimentation, they always think that you have to set up a very, very vast infrastructure, bring in a lot of engineers, throw data engineers and software engineers to the problem. But that is actually wrong, because there are pretty much a lot of things you can try at the early stage, especially when you have a small user base of maybe a few thousands and you want to test some ideas, right? There's also this hierarchy of evidence and experimentation that allows you to go from, rigor to rigor and improve the experimentation process. The very fundamental level is basically case studies and observational studies, where you can do stuff like, sharing questionnaires, trying to, ask your user base some questions, just doing basic observational studies where you can just run correlation analysis and things like that. Then the next step is to run controlled experiments, where you're going beyond correlations in data to actually sort of finding out what is the marginal impact of these particular factors, in our data. What is the marginal impact on the business outcomes, right? Then there's an even more rigorous method which builds on the previous step of controlled experiments. It is randomized controlled experiments, which is pretty much your live A/B testing, where you now create a more rigorous process of distributing your traffic or whatever it is you're trying to test between the variants that you're trying to test. And then you, after the experiment, you measure and come up with insights from the experiment. And then that guides your decision making. The highest rung of the hierarchy of evidence is meta-analysis, pretty much a systematic review of experimentation, do very rigorous analysis, because it's not enough to have really successful results. Your p-value can do great, but you can be fooled by p-value, right? You would think their results are statistically significant, but when you subject to different decision-making methodologies and scenarios, you realize that, well, our meta-analysis shows that we can't actually go ahead with this decision. Either it's too risky or it's too costly, or there's some very funny trade-offs between different metrics that we're testing. Maybe one metric is improved and the other metric really lacks any, maybe metric is flat, or there's even a declination in the metric. You wouldn't want to go about making those decisions. So while the live A/B testing is the bar of rigor for experimentation, it's also very important to understand that meta-analysis is the crowning work on experimentation to ensure that whatever your results are, they are well tested, they are well validated, and you really have the right answers. So, of course, all these things I've said may make it seem like, oh, it's going to be very intensive, going to be very expensive, but no, it's not always the case. So that's what I hear a lot from organizations that don't want to invest in experimentation or even approach it, right? You can just do a simple statistical study. You don't need to stress creating any infrastructure. You analyze your data, you get the logs of your data. When you're done, you can move it to SQL. Your data is in the data warehouse. You can analyze within the data warehouse, just run simple SQL queries to analyze what you have. It's just basically, when you're done with the experiment, you now come to the normal default analysis that everybody's used to. And even when you're building infrastructure for large scale experiments, right? After the experiment, what happens next? You still need to come down to the level of analysis to analyze the experiment and the results of the experiments, and to get meaningful insights from that. So I would say that's a very high level overview of what experimentation is. And it's also very important for organizations, because it doesn't make sense to really go ahead making decisions. Let's say you want to decide when to launch a product, right? Or you want to decide whether to increase a particular campaign for a section of your users. How do you decide all those things, right? It's not enough to just do trial and error and just push the intervention to your users. You need to be able to test, and that requires using the right experimentation methodologies. But if you cannot run fully rigorous, randomized, controlled experiments, then you can come down to very simple observational studies, right? Except that, of course, you will need to be very careful about the claims you make from the results of the experiments. So that's pretty much a high level overview.
Thanks so much, Zion. Really, really high level overview. So I know, guys, you may be thinking that these stuffs are really, really enormous contents to take in. In the description below, I'll be sharing a link to a GitHub repo that has lists of resources about experimentation, blogs, articles, videos. I think it was compiled by Chris, if I get the name correctly. So you can dive into it and see what you can get out of there. Thanks so much, Zion. So something you said really was the impact of experimentation on business KPIs. And then so now this brings my next question. Why is that businesses do not want to pay attention to experimentation? Because typically there's so much attention paid on maybe data engineering these days, normal analysis, you visualize the stuff, they now jump to ML, like you said, without even having the foundation. But then you try to explain to them about experimentation, nobody seems to care, right? What do you think the driving factor for that?
So I think um, it's a global problem, actually. It's not just Nigeria. You'll be surprised that even some of the large organizations around the world, some Fortune 500, are not yet, at the executive level, senior leadership level, leaders are not yet sold in on the value of experimentation. And I think this is, very unfortunate, and it has really slowed down the growth of data science, really, because when when organizations run machine learning and eventually it fails, or they cannot sustain the budget on their machine learning models, they just, sort of relegate the data science team to, maybe simple analytics, reporting, and things like that. So you have a lot of people doing data science, but they're not really doing data science, right? Meanwhile, there's a lot of value in experimentation, but senior leaders don't see it yet. And the reason they don't see it yet, I think it will partly be because we data scientists are usually very technical and are not always very thorough in communicating the value of data science initiatives, right? So we just really want to get our hands dirty, build solutions, deliver it, and say, okay, this machine learning model is delivering value. But when you now talk about, okay, let's experiment with this, organizations feel like you're going to waste time experimenting. Why not let's push our machine learning models into production? Why not let's just take this decision and do trial and error? If it doesn't work, we abandon it, right? So they feel by experimenting, you are wasting time on, rather than going rather than being an executioner, be they're just pretty much wasting time and dilly-dallying on data science initiatives. So that's pretty much some of the reasons why organizations are not sold in on the value of experimentation. So what needs to be done is really to be able to consistently communicate this value across the organization, communicate this value to C-level, communicate this value to the board, leadership board, and all that. And another thing that helps is really to talk in their language. So you don't want to be talking to a senior leader that's not really technical about, let's analyze this, and get the p-value of this and that. We'll see if we can launch this decision. They don't really care. They care about marginal gains. They care about, what is the dollar gains of running this initiative? How much am I going to make? If I put down this budget, even if it's just $10,000, I invest into this initiative. Is it going to amount to hundreds of thousands of dollars, probably even $1 million? And if I'm increasing the investment in these initiatives, is it going to amount to increasingly improved business metrics? Senior leaders want to hear about money. Even if you have technical leaders, eventually technical leaders become so business oriented that they no longer care about your technical jargon, right? So I think part of the drawbacks is that data science field is still growing, and we are learning how to really communicate that value. So one of the things that's helping nowadays is that we're not having data leaders, the management level and on the executive level, but mostly on the executive level. When you have head of data or director of data or even a chief data officer, it helps a lot to have a representative and someone who is representative of the initiatives on the board, and he can convince the board. He has the understanding of strategy. He has understanding of alignment with strategy. He knows how to communicate execution. He knows how to communicate the value in these data science initiatives. So I think in Nigeria in particular, we still pretty much have a long way to go. But if we really want to solve, the issue of C-level not getting sold in on experimentation, one of the things that we really need to do, apart from just communicating the value in a way that C-level get interested in, right? We also need to present use cases, right? So how does Spotify do experimentation? Spotify is a great company, right? They you have even the CEO talking on experimentation in the annual report. That's the best you can actually have in an organization. When the CEO himself is talking about the value of experimentation, is talking about the experimentation initiatives they run cross company, cross organization, and how the thing impacted on their metrics. That's the dream of every data science team. We want senior leaders to be able to talk about it. Most importantly, if the CEO can understand it and can be talking about it and can be creating literacy across the organization, that's pretty much the best you can get. So for us to improve it, we need to be able to present these use cases. Spotify did it, Airbnb did it, Netflix did it. Without experimentation, they will not be successful. They will not be where they are today. Netflix did experimentation to the point that they maxed out on the possible number of users they can actually test in an experiment. They maxed out because when you start testing, okay, 1 million users, the next moment your user base increases, scale to 100 million, the next moment you scale to 1 billion. By the time you start getting to 4 billion, 5 billion, 6 billion, you already start having a problem with, you're no longer getting new users, right? So they actually really maxed out on the possibilities of experimentation. And now they're looking for more innovative ways to really monetize those users, because now you cannot really talk about let us increase our user base. You have really got it to the bar, right? So if anything, maybe you're just going to be adding a few millions after some months, but you're not going to be having that rapid increasing number of active users on the platform. So they're pretty much maxed out on experimentation, and they still run experiments, thousands of experiments, because they understand the value. But what are they doing now? They are, looking for innovative ways now to maximize the decisions that have been presented, or should I say illuminated, by those experimentation initiatives. So it boils down to communicating the value and also, presenting compelling use cases, right? There's a saying that, only fools without proofs. When you have presented enough proofs about why senior leaders should be sold in on something, using all the business language and strategy language possible, if they still doubt it, then you have to really consider whether that's really a team to continue working with, right? So when you present enough proof, as long as there's evidence, right, then senior leaders will be sold in on these initiatives, and then you'll see them more and more inclined towards it. Then the next step after that, after you have gotten the necessary buy-in within senior leadership, is to begin to now advocate, carry out experimentation and advocacy across the organization. Product managers should be oriented about experimentation. Project managers, engineering managers should be oriented. Pretty much everyone who is going to be involved, including C-level leaders, C-level leader in marketing, C-level leader in strategy, C-level leader in various areas of the business that are really key in terms of decision making. They need to also be oriented about it. And the more you orient these leaders, the more they are also able to communicate the value of these things across the organization in a very simple, of course, leaders speak in a very simple language. So they are able to communicate it in a language that is as simple as possible to make the rest of the organization to really get sold in on the idea of experimentation. Before you know it, you have every team literally experimenting. And that's why some of these companies like Netflix, Airbnb, they are now running thousands of experiments. Nobody just woke up one day and said, let's do 1,000 experiments, right? It started from 1 or 2 experiments that they got buy-in for, and it succeeded. And when it succeeded, they started advocating for experimentation across the entire organization. Every product line gets experimented with. And that's how the number of experiments being run across different product teams and different engineering teams began to increase. And now you have, experimentation at scale in these organizations. So when you present the compelling use cases, right, I don't see a reason why senior leaders will not really get interested and, be able to now communicate that these things can actually generate as much impact as possible to the organization. So yeah, pretty much it.
Thanks so much, Zion. One of the major things I've gotten from what you just said right now is that in these organizations, experiments drive innovation, right? So you mentioned Netflix, Airbnb, Spotify. These are innovative companies, right? Who are turning out products that are working, features that are working and bringing out results. And we can tie these things back to these organizations. Another question from this standpoint, right? So notice that organizations using this experimentation in a very large scale, first small scale, are actually big tech. Airbnb, Netflix, Spotify, Facebook, Amazon, and the rest. Do you think there's a resource problem for which small organizations, in quotes, are not really experimenting? Do you think there's a resource problem, maybe human resource issue that's affecting that? Do you think so?
It's a great question, actually. When you think about the examples I've given, it looks like, okay, it's larger organizations that are really running these experiments. And it's true, larger organizations now, gradually they go to that level where they can run those things and now they trust the process. It's a lot harder when you are dealing with a small organization, but doesn't mean small companies are not running experimentation, right? You ask the question, could it be a resource problem? Could it be maybe financial resources, team resources? They don't have enough resources to really place on the experimentation initiatives. I would say no, it's not really a resource issue. But I think when you look at some of these organizations like Netflix and Airbnb, they were never big tech from the beginning, right?
Okay.
They started from somewhere. They started from, being a small to medium tech. In fact, they started up and then growing into small tech, medium tech, and eventually big tech. In fact, some would argue that Airbnb is not big tech. Netflix is big tech, right? But Airbnb, some would argue that Airbnb is not yet big tech. But I would say these are big tech because what makes an organization big tech is the volume of data that they're generating and the scale of the technologies they're using to process this data. So when you have like less than like gigabytes to maybe a few terabytes of data, you will call that maybe small scale, right? Mostly gigabytes. When you begin to talk about terabytes of data being generated every day, right, that's medium tech. When you're talking about petabytes of data, that's big tech. So some organizations even generate petabytes of data every hour, on their platform. So the scale of technologies that you need to handle this inflow of data and all the decision-making process is what really categorizes you as any of the categories of tech. For the likes of Airbnb, Netflix, before they got to this big tech scale, they had actually really started in experimentation initiatives. I think Netflix started way back maybe 2015, if I can remember, or earlier than that, I think. Airbnb, of course, Airbnb is I would say less than 10 years. I'm not very sure of the exact number now, but they didn't, get to this point before really starting experimentation. So like I said, it's just pretty much, it starts from just one experiment, then it scales to 5 experiments, then it scales to a dozen experiments, and then you maybe have hundreds of experiments running. For small organizations, right, you might not necessarily have to do hundreds of experiments, right, or just start from one. So how do you do that if you're thinking about resources? You don't want to throw in so much budget into it, and maybe you don't even have the staffing for that, right? As long as you have one data engineer, one data analyst, and one data scientist. In fact, a data scientist can double as the data scientist and data analyst to handle this process, right? Or a data scientist can also double. There's been so many cases like that where a data scientist doubles as a data scientist and a data engineer. So if talent is a problem, I'm not advocating for a data scientist to be over responsibility. But I'm saying that it is a practice actually in small organizations nowadays where you have data scientists. And what are they doing? They're not doing so much of deep dive, like hardcore experimentation. No, what they just do is that they just check, okay, what is the data coming from our users? So when we have something to test, we create the design the experiment, right? So the simple way we've been serving whatever it is to our users, or we've been generating data from our users, we continue doing the same thing, except that now we now begin to monitor for specific things, right? When data now comes in after the timeline of the experiment, you can now get that data, then analyze it. So for a team where you have just a data scientist doing the data engineering work, he handles things like logging of the data observability, data quality issues, and things like that. On the science side, he handles the experimental design, and when you launch the experiment, that's pretty much now the engineering side that takes over. And when you're done with the experiment, you get to pull the data and you want to analyze it in your data warehouse, or if you want to pull it out of your data warehouse, maybe you want to analyze it in Spark, or depending on the size of the data, maybe you can even do Python, or maybe you go for Dast, right? By the time you pull out this data now, you now start doing your statistical analysis and statistical tests. Data science comes back again, right? In fact, this is, depending on what methodologies you're using, a data analyst can handle this, right? So the point is, if budget is your issue, right, with the right motivation and with the right incentive, you can actually have a data scientist being motivated to carry out, those different aspects of the procedure, right? So maybe if there's any issue, it might be on the software engineering side, in which case your app developers or whether it's a website you're running or a web app or a mobile app, the developers handle all those things around data production upstream. They handle all those issues about the software, the pipeline, the APIs, and things like that, right? Of course, we have data scientists that are writing APIs. It's not supposed to be, but you have organizations that do that. So what that simply means is that with the right examples and showing the right use cases, can actually convince senior leadership that even small organizations without so much of resources are getting into experimentation. Right? You have, I was looking at Germany just earlier this year. I was looking at some organizations in Germany, how they do data science, how they do data engineering, and I was seeing really impressive organizations, some organizations that are into talent management for part-time staff, right? If you want to work part-time in Germany, there's a platform where you can just get matched to the employer who wants to give you the part-time job. You get paid per hour, So there are so many of these organizations doing stuff like that. And one of these organizations in particular that I was looking at was really, talking about, okay, we are about to start some experimentation initiatives, that we have been doing machine learning just to carry out the matching. So all along, they didn't have like a data science team, a core data science team, because they didn't want to jump into it. I'm talking about a startup right now, right? They didn't want to jump into data science and start pushing out predictions. So the only machine learning models they had in production were models that were doing the matching, the recommendation system to match the talent to the employer that wants to hire them, And then another model that, they were not talking about, they wanted to start working on is demand forecasting, how they demand on the B2B side, how they forecast demand from the employers on the platform, and then from the B2C side, how they forecast the demand from the from the customers, the talents on the platform. These were just like new initiatives. But prior to this, the only data science initiative that was really running in the organization was this recommendation system engine. And for that, they didn't really need to have a full-blown data science team doing some fancy machine learning. But now they got to this point where they now said, okay, we want to start experimenting with our users, right? We want to experiment with various demands of these users. We want to experiment with dynamic pricing where we can, manually adjust the pricing compensation for talent and even the charge that we give to employers on the platform, So B2B dynamic pricing and B2C dynamic pricing, they wanted to start all these things. This is not a machine learning problem, right? Dynamic pricing is an optimization problem. And one of the methods to tackle optimization problems in data science is to experiment. Of course, there are other optimization techniques, we borrow from the mathematical department, different optimization techniques, but we can also run experiments. So this organization was talking about, so we want to start experiments. So for that reason, we were not interested in actually having a data science team and a data leader. When I was reading about this, I was really, I found it very impressive. And I was like, yes, I think this company is on the right track. It's a startup, right? So they just maybe raised a few tens of millions of dollars in maybe Series A funding. So it's not like they're already full blown per se, but they're already thinking experimentation. And when they want to start these things, they start from a small scale. So they start by, just having a data scientist and maybe the software engineering team looking at, okay, let us, create these connections and let us log this data this way. Let us have this kind of table in a data warehouse and let us, be gathering data about this specific thing we're trying to test. And, you don't need to invest too much. If it succeeds, right, you go into more sophisticated experimentation. You can just start from maybe their data science team. We have one data science scientists. Let's get the collaboration with the software engineering team. They create the necessary connections, they log the data, they create all the observability for the data to ensure quality and reliability. And when the data is ready, when the experiment is done, they can start from a simple correlational study, an observational study, right? So the observational study we present. One thing correlation does is that even though it's not a full-blown way of fully validating ideas and determining the causal impact of a particular variable or the metric, right? What correlation helps to achieve is to present what variables, it shows you what variables have the highest or the best or provide the best opportunities for the metric of interest, right? So you begin to now see, okay, these particular variables are actually the ones that we should focus on, right? And then you're able to present some of the biggest opportunities to improve the metric. The metric could be revenue per user. The metric could be monthly active users. So many different metrics that you may want to improve. Correlation helps you understand which particular factors in your data have those higher likelihood of impacting the outcome. But likelihood is a keyword in any observational study. You can't make causal authoritative claims, right? So yeah, I think that's pretty much it. So you can see a team like this, despite that, yeah, they've already raised some Series A funding. They can actually start throwing a very big party on their data science initiatives, but no, they start from a very small scale and expect experiments to fail. That's a mistake a lot of people make. So I think another thing that affects the adoption of experimentation in organizations is that sometimes senior leaders feel like, okay, we'll allow you, give you till maybe between now and the next 2-3 months to prove out the value of experimentation. They give you that. Now you begin to run the experiments, and experiments are failing. You're not seeing any marginal impact on the KPIs. Yeah. You are not able to really really optimize decision making with the experimental results, and some senior leaders just feel like, okay, that's it. We can't continue with these initiatives. So like I said earlier, advocacy. One of the things that you do in advocacy is to make everyone understand that experimentation is not a what's the word? Is it a golden
Magic bullet.
it doesn't mean when you run experimentation, when you run an experiment, boom, we have very impressive KPI increase. No, not necessarily. But what every experiment does is that even if an experiment fails, every experiment creates a particular kind of insight. It helps us to learn. It helps us to understand what went wrong. It helps us to understand that, okay, maybe if I did this thing, it will not have actually impacted my decision. So let's say you wanted to test for a particular, you're working with thousands of users, and you wanted to experiment with test like a particular factor, maybe a particular geographical location, and you are serving a campaign to that location, but you're testing, so you're not doing this to all your users in that location, right? Let's say you just you randomize it and serve a particular portion, and then maybe you do an actual A/B test, and then you vary between the default implementation and then this new intervention that you're trying to apply on the second variant, right? What if you're done, and then when you test the results, your intervention didn't create any marginal impact on the KPI, right? The experiment failed. Does that mean that you just abandon the experiment? So, okay, we're no longer doing experiments. We'll not run the experiments anymore. No, the experiment has created a particular kind of insight. So, I mean, in companies like even some of the biggest companies, all these Airbnb, Netflix that I mentioned, you have these organizations that sometimes the experiments, they only have like 20% winners among the experiments, right? Some organizations manage to have 40% winners, which means only 40% of the results of the experiment passed, right? The rest, either they were flat, so there was just a flat, there was no uplift, right? Yeah. There was a flat KPI. And some even have they even cause some downward negative impact on KPIs, and that's it, they failed. But does that mean you stop experimentation? No. Bring up the next idea, let us test it. So pretty much we don't want to, when we're running experimentation, the goal is so that we don't just use our intuition and say, I've been running this business for 20 years. I know about all the tech people. I know this more than you people. That we are the business guys here. We have been doing this and we've been using our intuition, right? That's what more senior leaders tend to say because they've been in the business. They've earned the right. Yeah, they've earned the right to actually talk that way. They have a lot of business wisdom that we tech folks need to learn from. But then when it comes to decision making, right? When it comes to decision making, we are fully rational and fully agent creatures. Humans are fully rational and agent, but there's always a limitation to our agency and our rationality. And so we will not always, a lot of sentiment will come into the decisions we're trying to make, a lot of emotions, a lot of guesses and all that. If we want to think logically 100%, we can. Of course, it will take longer to come up with a decision maximized from logic and rationality, right? But point is, it's not always the case. So some decision makers will look at it that, but this didn't happen last year or last 2 years. Why are we trying to do this now? So let us go this other way. Why? Because they've been in the business. But when you calm down and when you subject your ideas to actual rigorous testing that actually follows scientific methodology that has been proven over the years, I'm talking of over hundreds of years, right? When you follow that kind of procedure, you realize that your decisions become more reliable because before you make any decision that's been rigorously tested, and you are now having an optimal decision to take, really. So some experiments may fail, but the ones that succeed usually create the best impact on revenue. Let me give you a case study before, a very popular case study before I round up. I think this happened in Amazon. It's been like about 20 years back before Amazon began to see millions of users, millions to billions of users in their user base. When they were just a few, maybe 10 millions, right? They ran this experiment on their website just on the checkout button, and they just did a little bit of variations. So now this idea had been on ground. The engineers, there's this particular engineer that had been pushing the idea to the product team and to senior leadership, and nobody was really interested in it. One day he just felt, okay, I'm working at the back end. I can tell this idea and nobody would know. If the thing fails, right? Yeah. There's already guardrails. You can set guardrails so that there will not be negative impact on revenue, right? So if you just want to test for positive results only, you set a guardrail. You understand? So it was like, I will just set guardrail. Worst case scenario, the uplift is flat. We don't have any improvement on the KPI. and he just took that risk. He implemented just a very small change on the back end, did a little bit of randomization of the users, just wrote a particular experimentation around their back end, and boom, ran the experiment. Now, guess what happened? Suddenly, in a couple of days, Amazon started recording. They normally set this trigger alerts when there's a too good to be true revenue, like too good to be true.
Yeah.
So what they do is that, sometimes, I mean, if you're expecting a revenue of maybe $20 million for a particular business day, right? And you start getting 100 million, 200 million, you begin to wonder, this cannot be miraculous, because if you're expecting an improvement, we're talking about an improvement of maybe 10 million more if everything works so good. So from 20 million, you can be talking about maybe we get 30 million or $40 million in revenue, right? But now they started having spikes to their revenue, like explosive spikes. And so their system started triggering because it was like something is wrong. So maybe there's some issues at checkout, maybe some users are losing money, and they triggered all those alerts, and then they went to check what is causing these alerts. And then when they found out, they realized that all this is actual results. And then they found out that it was due to an experiment that this particular engineer ran, which they had actually really, pushed aside for weeks, probably months. And now this person ran it and it exploded. So that's it. So sometimes experiments fail, but most times the ones that succeed, right, they are usually so good that they create so much impact on the KPIs that just begin to wonder that, what if we didn't run this experiment? And it becomes an eye-opener. And you just need only one such success.
Right.
Once that one success comes in, the leaders are so, they get so invested in the process. And in fact, they don't mind, they throw in resources into it to ensure that you can continue to test and validate your ideas. So that's pretty much it.
Awesome. This is really, really amazing conversation, Zion. Really, thanks so much for this insight. So experiments fail, but they don't mean that you don't learn from your failures, right? So those failures will actually teach you, give you insights to things you actually thought you came with. I think even most times as data professionals, we actually come with a bias of our ideas, thinking that our ideas would work. But when you experiment them, your ideas actually work, right? And then you can learn from that. So finally, the last question I'll put out now would be a question around learning. Right. So what are like the best resources? Do you have books you recommend? Do you have courses you recommend to teach one about experimentation and how they can apply it right now in their organizations for improved growth?
Okay, that's a very good one. So there's actually a shortage of resources for experimentation out there, right? Not because there's no strong body of knowledge around experimentation, right? Experimentation as a scientific methodology, right, is older than statistical modeling and machine learning and all that. Experimentation originated in fields like chemistry, physics, where you have, some really sensitive experiments that you even have to set the p-value threshold to very low, extremely low, like 0.00001, so that anything you are getting from that, that it's a signal, not noise, right? So that's how rigorous experiments were from these scientific fields. But despite this very grounded body of knowledge, right, the body of knowledge on experimentation is not very accessible to people in the business world and in the industry and in tech in generally, right? So why? Because most of these knowledge is within research papers. All right. So you have research papers. Even tech people that are doing experimentation, when they want to talk about their results, right, they publish a paper because they're actually publishing a groundbreaking result that has not just an impact on the industry, but also on the scientific community. So they put it into papers. And we in the industry don't like really looking at papers, right? And so, the best thing we can do is maybe when someone decides to write a book on some of those research topics, and then they break it down to a level where technical people and engineers can appreciate it. But what I would say is that there are definitely blogs, right? So despite that there's a shortage of publicly accessible knowledge on experimentation, you still have blogs. If you look at companies like DoorDash, go to their blog, search for A/B experimentation. If you look at Airbnb, if you look at Spotify, check for their online controlled experimentation, and also check for observational studies. You see blogs on that, right? And then there are, some books that actually help with experimentation from the lowest level in the hierarchy of evidence, which is case studies, to observational studies, to randomized controlled experiments. There are books. So my two top recommendations, right? Practical statistics for data scientists. Yeah. So we have that this material written by it's a very useful resource I go through it every now and then. It's written by Peter Bruce and Andrew Bruce and Peter Gedek. Just check Peter Bruce, Practical Statistics for Data Scientists, and the sub headline, the tagline is 50 plus essential concepts using R and Python. So the motivation of the concept using R and Python. Now it's not very in depth into experimentation, but it's a good starting point, right? I even use it like if I go back with a lot when I have even something as simple as a correlation analysis or an ANOVA and go to it, right? In fact, right now I have a template for simple experiments when I'm just running simple statistical tests. That template I have that I created for my projects, right, is based on some of the things I got from that book, so that you don't really have to sweat it, right? So that is a very good foundation to start with. It introduces you to the fundamental statistical concept. So because without statistics, you can't really do experimentation.
Yeah.
Because when you want to analyze results now, you need statistics. So that's a good start. Another resource, which is now a more technical resource for people who want to really understand what experimentation is, from experimental design to experimental execution to experimental analysis, so the culture and management around experimentation, and how you can actually create successful experimentation initiatives along the organization, right? You have a book from a global experimentation leader, Ronnie Kohavi. His name is Ronnie Kohavi, and the book is Trustworthy Online Controlled Experiments. Trustworthy Online Controlled Experiments. The author was an ex Microsoft director of data science, ex Amazon, ex Airbnb. He actually when Airbnb started experimenting at scale, they brought him on board, and he was technical fellow, and at the same time, I think the technical vice president for that particular org. So he was managing over 100 data scientists and engineers in the experimentation group. So he has a very high level of authority on the subject. And pretty much is when it comes to experimentation, the final say on experimentation, I just take it to be him, right? Because even when he's skeptical about results or when he's trying to be careful, he expresses it carefully and makes you understand that, that we have to be careful in this scenario. So you can even follow him on LinkedIn. Just check Ronnie Kohavi, and then you learn from some of the things he says can be really, really like in-depth, but you get to learn a lot. So his book is mostly conceptual and executional. It's less of code. You don't have code there, right? If you want to really understand the concepts, well explained, like a teacher would explain to a student, that's pretty much a resource. So once I have these two books, I don't stress too much about, recommending resources to people who want to break into experimentation. If you have foundation in these two books and you really understand those concepts, of course, you won't understand it at once when you read Ronnie Kohavi's book. But over time, as you begin to implement those ideas, it begins to make a lot of sense. So when you have this, and then you begin to combine it with blog articles, and then Ronnie Kohavi's thought leadership on LinkedIn, right? You are able to know your left from your right. You're able to know who are the trusted leaders in the space, right? It is through Ronnie Kohavi I was able to have to know about who are the authorities in experimentation. Even people working in marketing, like there's some marketing leaders today right now that are so good at experimentation and the technical aspects of that. So I know, people. There's a lady, Deborah O'Reilly on LinkedIn. That's also really good with experimentation. So just follow their thought leadership, and gradually you get better. So I think that's pretty much my recommendation. But if you're scientifically minded, if you're the type of person that likes to read papers, then definitely go to archive.org and just go to, just type experimentation. I think you will likely see it in the computer science section. Go there, see how experimentation is done. You see papers, a lot of papers that are being, uploaded every week and every month. You will be able to have access to a very rich library of experimentation papers, and you'll get to learn some of the scientific methodology behind the methods that we use. So I think that's my general recommendation on the subject of experimentation.
Wow. Thanks so much, Zion. Like, this is really, really an insightful, mind-blowing interaction. Some of the concepts are actually alien to me, and I'm like, wow. I think most recently, we did a project in my current organization, as at the time I was recording, a startup, and I had to consult with Zion to help me think around some experimentation ideas I was trying to put through. So that's to say that wherever you are right now, you can actually begin to put in experimentation in your workflow and try to gain value out of experimentation. All the resources he has mentioned, I'm going to put them in the description below. his LinkedIn handle, so you could go there and follow him, and follow on his thoughts, his Twitter handle as well, so you can learn from him. And this video, you may have to watch it a couple of times to have all these thoughts and concepts inside of it. Yeah, thanks so much everyone for watching. Thanks so much, Dan, for coming to have this conversation. Really, really insightful here for us in the community. And we trust that in the coming years, Nigeria data space would actually have grown, evolved, and matured in such a way that we'll have organizations thriving in experimentation. All right, thanks so much, everyone. Thanks so much, Zion. All right, so
Thank you very much for having me. Yeah, it was a great session.